Hello, everyone. Welcome to the first lecture video of the week. This should be, if you're going to stick to the class schedule, you should be watching this on Wednesday at 10:10. So, whatever, you can watch it whenever you'd like. But we're going to start the new chapter, which is called linear programming. This is going to feel more like regular math to you. It's going to feel more like algebra. Um, so, if you were good in algebra, this should be a pretty easy thing. If you're good in graphing lines, this should be pretty easy. If you weren't, well, we're going to get through it together. And I think this is one of the easier topics in the course. The only problem we have with this topic is graphing stuff on MyOpenMath. But once we reconvene together in person, quote unquote in person, we'll spend a lot of time showing how to graph stuff on MyOpenMath because their interface can be a little bit tricky. But basically, that's all we're going to be doing in this whole chapter is just graphing lines, finding intersections, and things like that. Okay. So if you don't know where these notes are on our Blackboard page. If you go to our Blackboard page, I have a bunch of stuff up here. So this is our Blackboard page. More or less looks the same for you. If you go to course materials, and then click Unit 2, Linear Programming. It should be the linear programming notes. You don't have to look at the textbook chapter. That's something different. Just look at the linear programming notes. That's what I'm using for this. So you can print them out or use them digitally on like an iPad or something, but that's what I'm using for these videos. Okay, so we're going to start off real simple. So if this stuff seems easy, that's okay. We will eventually get to stuff that's a little bit more challenging. But I know for most people, this is probably something you've done a lot of or done recently. So just embrace it while it's still really, really straightforward stuff. So I have this equation here that is 8x minus 2 equals 11x plus 7. The goal, whenever you're solving an equation, is to get all the variable terms on one side and all the constant terms on the other. Very similar to what we did in finance, okay? You want to get the variable alone and the constants and everything else on the other side. We're going to do that by applying the same operations to both sides of the equation. Whatever we're going to do to the left, we're going to do to the right to maintain that balance of equality. So I'm just going to solve this and write out each step that I take. So this first equation says we have 8x minus 2 equals 11x plus 7. So if you have a variable and a constant on both sides, it doesn't matter what you move first. Anything you move will be a move in the right direction. So I'm just going to take this negative 2 and I'm going to add 2 to both sides. Because if I add 2 to both sides, this negative 2 and this positive 2 will go away. So that gets rid of that constant there. So the left side is just going to have 8x left equals 11x. Now I have a 7 plus 2 here. So that's going to be 11x plus 9. What did I do? I added 2. You don't have to fill out that side if you don't want. I'm just doing it so people can revisit their notes and see what we did. So now on the left, all I have is 8x. So I'm just going to leave that there. So I have to get rid of this 11x on the right-hand side because I want all my x's on the same side. So this is a positive 11x. So to get rid of it, I'm going to subtract it from both sides. Subtract it from both sides. So now those go away. I'm kind of cleaning up this thing, right? Put everything in its proper place. So on the left-hand side, I have 8x minus 11x. I'm left with negative 3x equals 9. What did I do there? I subtracted 11x. Again, you could take different steps as long as your answer at the end is the same, and it should be if you do everything correctly. You don't have to follow the exact same procedure we do. But your endpoint should be the exact same. So now this is always going to be your last step. You're going to have one variable term on one side and one constant term on the other. So the last step is always going to be for these problems to get rid of that coefficient. The coefficient is the number in front of the variable, and it's negative 3 times x. So to undo the multiplication, I'm going to divide both sides by that coefficient. So 3x, negative 3x divided by negative 3, those negative 3's are going to go away. So the left side just becomes x. 9 divided by negative 3 is negative 3. So I'm left with x equals negative 3. And I divide by negative 3. No matter how you solved it, that should be your final answer. If you took different steps, that's okay. Okay, so I'm just going to write out the steps just in case you need to revisit them. I don't know if you will, but so we have here, let's see here. So step 1. I'm going to add an extra step that we didn't do here, but we'll do on the next page. Multiplication. Eliminate any parentheses or denominators. Denominate early for me here. Let's fix that. Okay, that's your first step. Through multiplication, and I'll explain what that means on the next page. Eliminate any parentheses or denominators. Next step, through addition and subtraction. Get all variable terms on one side of the equals and all constant terms on the other side. Doesn't matter which side you put, on what side, variables on the left, variables on the right. I tend to put variables on the left, it just looks better, but that's not how you have to do it. And your last step is always going to be divide by the coefficient of the variable. Those are the only 3 steps we're going to do. Okay, pretty straightforward stuff. So the next question is going to ask us to do this first part. So we have parentheses. So the first step said through multiplication, eliminate any parentheses or denominators. So to eliminate these parentheses, I have a 2 out in front. I'm going to make this multiply this. This means 2 times that term and 2 times that term. These terms live together in the parentheses. 2 stopping over to say hi. You have to say hi to both terms. So I'm going to take this 2 and multiply it by both terms. This is called distribution. Oops. No. So I'm going to say, okay, well then 2 times 4x, that's going to give me 8x. 2 times 5, that's going to give me 10. That minus 3x stays there. Equals 24 minus 2x. And I just distribute the 2. Okay. From there, I actually forgot a step. So you don't have to add this in. I'm going to add it into my steps here. Technically, you should be doing this. So let's do this. Combine like terms. I'll explain that in just a second. This is going to be. I apologize if you have to rewrite that, or you can just add it to at the bottom and put an arrow up. That's fine. All right, so I have more than one x term on the left-hand side. So that's why I had to add that second step. So I have an 8x and a negative 3x. So before I can move anything, I just want to clean this side up. So don't switch their signs. Like in the first problem, I would say, all right, well, there's a 3x, negative 3x here. Let's add it. If they're on the same side of the equal sign, just combine them the way they are. So this is going to be 8x minus 3x. That's 5x plus 10 equals 24 minus 2x. And there I combined like terms. Now we're in the same boat as we were in the first problem. Pretty straightforward. You can move anything. I'll get the variables on the left-hand side again, so I'm going to get rid of this negative 2x by adding it. Add 2x, add 2x. Boom, boom. I'm left with 7x plus 10 equals 24. There I added 2x. So this is step 3. Through addition and subtraction, get all the variable terms on one side, all the constant terms on the other. So my variable terms are on the left. Now I'm going to get my constants on the right. So I'm going to get rid of that 10. Get rid of that 10. So I have 7x equals 24 minus 10 is 14. I subtracted 10. So once I have all my variables on the left and all my constants on the right, the last step is to divide by the coefficient of the variable. Divide by that number in front. So I'm left with x equals 14 divided by 7, which is 2. So we divide by 7. Okay? Just following the rules, following the steps. All right? Okay. If you watch these tomorrow or today and you just have any questions, you can email me. I can try and explain it through email before we meet again next week. But it should be pretty straightforward. All right, example 3. It says 3x divided by 5 plus 7 equals 25. Some of you may want to solve this a different way than I do. I like to start by eliminating all the denominators right off the bat. Okay, but some of you might want to subtract 7 and multiply by 5. That's fine as well. But if you go back to my steps on the previous page, it says through multiplication, eliminate any parentheses or denominators. So I want to get rid of that 5 first. So what I'm going to do is I can't just multiply the first term by 5. I'm going to multiply the entire equation by 5. Because I can't just do something to one term. I have to do that thing to every single term in the equation. So this, I have parentheses now with a 5 in front, so I'm going to distribute, just like I did above. But now it's to everything in the equation. Okay, so this first term is going to be 5 times 3x over 5. So I have 5 times 3x is 15x over 5. Plus 5 times 7 is 35. Equals 5 times 25 is 125. Now, why did I multiply by 5? Because there's a 5 here, and this will cancel. 15 divided by 5 is 3x. The denominator went away. Plus 35 equals 125. Okay? So, easy enough. My variables are on the left-hand side. So now I can get rid of this thing. Get rid of this thing here. Get minus 35 on both sides, not 33. So I'm left with 3x equals 90. And then our last step is always to divide by the coefficient of the variable. So I'm left with x equals 90 divided by 3, which is, whoops, there's that stupid e again. Whenever I click the button on the pen, this e pops up. I don't understand. No. I want to delete that. Okay. Now I'll get rid of all that. And we have x equals 30. There we go. Okay. Again, you can solve it in a different way as long as your answer matches mine. X equals 30. Now that's the only examples the notes give, but I do want to go over 2 other specific problems. Give me 1 second to figure out which ones they were, because they have very unique answers. But you can feel free to try all of these. Okay, they're all worth your time. They're good practice. You can always email me if you want to know the answers. I can go over them with you. But let's see here. So I want to do number 6 with you, and I want to do. Let's see here. There's another one. Then 6 and 8. Okay, so let's do 6 together. So this is going to be, I'm just going to rewrite it. 3 times the quantity 2x minus 5 equals 6 plus 6x. So I have parentheses. The first thing I want to do is multiply to get rid of these parentheses. So I'll multiply the 3 by each term in the parenthesis. So this is going to be 3 times 2x, which is 6x. 3 times negative 5, which is negative 15, equals, just rewrite the right-hand side, 6 plus 6x. Okay. So then I'm back in the same boat I always was. I want to get everything on the one side. So I'm going to get my variables on the left-hand side. Again, you could solve this by adding 15. You could subtract 6. But I'm going to subtract 6x from both sides. Well, my variables on the left-hand side. So you'll notice that these 6x and this 6x goes away. But then we have a problem here. We have 6x minus 6x they go away as well. Something minus itself is always 0. It's not 0x, it's just 0. You have 6 apples and you take away 6 apples, you just say you have nothing. You don't say I have 0 apples, you say I have nothing. So we're left with negative 15 equals 6. If you solved it differently, if you added the 15 first and then subtracted 6x, you would have ended up with something like this. 0 equals 21. If you subtracted 6 first, you would have got negative 21 equals 0. It doesn't matter what you did. You could have gotten 15 equals negative 6. Those are all the possibilities of answers you could have gotten. Okay, doesn't matter which one. As long as you get something that doesn't make any sense. Negative 15 does not equal 6. That's a not true statement. And there's no x's left. So that means there's no value of x that could ever make this thing be true. No matter what, it's always going to make no sense at all. It's going to be a false equation. Okay, it cannot be true. So on MyOpenMath, when this thing occurs, there's a specific way you answer it. So you can say something like, well, technically this is what we call a contradiction, a mathematical contradiction. You won't have to remember that. That's not going to come up on MyOpenMath. But when you get something like this, since it's not possible, we just say, and then you have to say this, no solution. On MyOpenMath, there's just a box or a little circle you click, no solution. Okay. When you end up getting something that doesn't make sense, there's no possible value of x that makes it true. Like, just look at this easier example. If I have x plus 2 equals x plus 3, there's no number, no possible number, that when I add 2 to it, I get the same thing as if I add 3 to it. So this is also no solution. Okay? That's important to remember. Now the other guy, see if I can fit it here, is number 8. So we have 4 plus 3x equals 2 times 5x plus 2 minus 7x. Same thing. Start by distributing that 2 to both terms. I have 4 plus 3x equals 10x plus 4 minus the 7x. Okay. So I'm going to combine my terms on the right-hand side, 10x and negative 7x. So this left side stays 4 plus 3x equals 10 minus 7. That's going to be 3x plus 4. Okay, let's just assume you didn't realize that these are the same thing on both sides. So you move something. So I'll move, I'll do 3x from both sides. So negative 3x, negative 3x. They cross out, they cross out. I'm left with 4 equals 4. Let's just assume then you still didn't know that the left and right hand side were the same. You could subtract 4 from both sides and you'll get 0 equals 0. Notice on this thing, the right hand side, the x's still go away, right? There's no x's involved in my answer. So, but now we have a solution, not a solution, but we have a situation that makes sense. 4 does equal 4 and 0 does equal 0. Here they didn't make sense. Here they do make sense. So on the left-hand side, there was no value of x that made this equation true. On this side, every value of x makes this equation true. This is called an identity. It's a mathematical equation that's always true for all values of the variables involved. Okay, and when we have this situation, there's certain things you have to say. Well, I believe on MyOpenMath, the correct response is infinite solutions. there will be a little box there if you get something like this when solving these equations, infinite solutions. And if we were taking this course in person, there'd be a little dot there. You could say all real numbers. All real numbers. Or you could write the symbol for all real numbers, which looks like an R with 2 lines through it like that. But this infinite solutions is the answer that MyMath is going to accept. Okay, so those are the 2 situations that you could run into when solving equations on MyMath. So I would suggest, if you have time, do I have it up? Let me pull it up real quick. All right, let's pull up our course. No, there we go. You go to linear programming. Let's see. There's not even any practice problems for this, so I guess you could hold off on practicing this stuff. So then, in that case, I would just say take some time, maybe try some of these other ones we didn't do. And if you get an answer, plug it back in for the variable x and see if it works. If you're not getting something, you're confused how to do that, you can always email me with questions. But before Friday, I will send you the next set of notes, which is on graphing linear equations.